the next one that was requested the most often. In number 18, there's 5-ish questions, but really only 2 math problems that you have to do. The main idea behind number 18 was to kind of reinforce what a lot of us thought we saw in the pendulum lab. And I put this in the email that I sent to you guys. A lot of you were talking about how you noticed a small or slight trend as mass increased in terms of the period of your pendulum. But what a lot of us didn't account for when I was reading through your procedures was the fact that as you had larger and larger masses you were using, they were longer. And so the length of your pendulum actually was increasing by a couple of centimeters every time you hung a new mass on there. And it got a little bit longer, a little bit heavier as well. And so that was the small, slight trend that a lot of us were seeing there. And that's why I have number 18 on this particular worksheet. So for the first part, number 18, I actually didn't put a letter on it. You just have to use your period equation. T is equal to 2 pi square root of L over G in order to calculate the period of the pendulum. And you should get about 0.77, 0.78 seconds for the period. Letter A and letter B then ask you what was the period of the pendulum if you added more mass to it. And literally all I want you to recognize is that the letter M does not appear in that equation anywhere at all. And that's quite literally what I put. If you check out the answer key, which is on Edmodo already, I'll put a little video on how to find it if you guys are struggling to find it in there. But because mass doesn't show up in there at all, it wouldn't affect the period of the pendulum in any way, shape, or form. From there, I asked what would happen if you double the length of the pendulum. And length is in here in the radical. Normally, in the numerator, and you double the length of the pendulum without that radical being there, you would double the period. But that's not the relationship that actually exists. It's the square of the length divided by gravity. But because it's still in the numerator, it is going to increase. It's just not going to be one of those really easily identifiable, hey, this doubled, so that doubled, or this doubled, so this gets cut in half. It's not going to be one of those relationships because of the square root. But you still can go in and solve for it. Square root of this would wind up being 0.3 divided by 10 because you're doubling the length of that pendulum. I believe it was 15 centimeters originally. Yeah, 15 centimeters. So now it's 30 centimeters. Remember to convert to meters. And you'll find out that that period does in fact increase. It should be about 1.09 seconds, not double, not 0.14, but still larger.